Hello Bellevue College. Today we are going to do part B of the Ionic solutions experiment. So we are going to start by taking our lab quest, which we have right here, and I already hooked up the conductivity probe, so that is attached and it is reading in microseconds per centimeter. Then we have our setup here of a clamp on a ring stand with a stir plate, a 250 ml beaker with a stir bar inside. And all of that will become relevant very soon. And so next we are going to measure out 100 milliliters for the sodium chloride solution that we're making. 100 milliliters of distilled water. So I'm going to pour it out and then I will show you, because you'll want to read the grad cylinder to the 0.1 milliliter, and I'll tell you what I think is the volume it's at, and then you can use your best judgment, since it's kind of hard to see a grad cylinder on a video. Make sure all the bubbles are popped. Here we have our meniscus. And it looks like it's below the 100 ml line. My best guess for this would be around like 99.1 or 2. So I'll let you choose what you would like to put. We're going to add the water solution to the 250 milliliter beaker. Then we're going to take our conductivity probe, and before we start, we're going to, you see this, rinse it into this large beaker here just to make sure it's clean. Let's get this on. It's not done, that is done. I need to put it into the clamp. We'll lower it down into the solution, close to the wall, but not touching the wall. And we want to submerge it close to the bottom, but also not touching the bottom. That. And then, just like in part A, we're going to go back to the lab quest, and we are going to zero it out because we want the solution to, or the lab quest to read the, there we go, the conductivity of the sodium chloride in the solution, not anything else that could be in the water. So when we have that zeroed, we're going to move on next to measuring out some sodium chloride for the experiment. Alright, so now we moved over to our scale. We turned on, and I have the white paper on there ready, and I've already tared it, or zeroed it. So now we're going to add to between 0.1 grams of sodium chloride and 0.15 grams of solid sodium chloride, which I have right here. You can see. So we're just going to add a teeny amount. Alright, since I added too much, we're going to make sure not to put the solid back into the original container. And I'm going to put it in this beaker I have here for waste, because you don't want to put anything back because it could be contaminated. Let's see what we're at now. Alright, just a little bit more. Okay, so it looks like we have, let's see if it staples out. Okay, so we're gonna go with having, oh no, do we agree that it's at 0.14 grams? Seems like it stayed there. Okay, so we're gonna go with that. And you wanna record that amount of sodium chloride into your data table in your lab notebook. And so from there, we are going to go back to our probe. Put that aside for a second. Okay, so now we're back at our probe. And so how we're gonna do this is that we're gonna add the sodium chloride to our water solution that we measured out. And then we're going to start the lab quest and read the conductivity as the sodium chloride dissolves. So after we get started, I'm going to show you a graph as it's happening of the conductivity values, and then we'll go over the highest and the lowest points so you can record those in your notebook, and then we'll move on to the next part of part B. So we're going to start by turning on the stir bar. You want to keep it away from the conductivity probe. We want to get it so it's creating a small little vortex. Alright. And then we're going to go back onto our lab quest. You see that our probe is still 0, which is good. Okay. And then keep this. So I'm going to go over to the graph feature. So you're going to want to pay attention to the x and y axis. So on the y-axis, we have conductivity, which I said before is in microseconds per centimeter. And then we have the time. So we're going to run this until the conductivity of the sodium chloride solution we're making plateaus, because that means all the sodium chloride is going to be dissolved. So simultaneously, I'm going to add the sodium chloride to the beaker and then hit start on the graph, and then I'll start showing you the graph and you can watch it dissolve in the beaker. On your marks, get set, go! Okay, so you can't really see both. So there's the graph starting. You can see that there's still some solid in there. And just let it keep going. So it keeps climbing. Looks like we still got a little bit of sodium chloride in there. And if you look at the graph, you can see that it is plateauing. So I'll let it run a little bit longer so we know that we're at a flat point. It looks like everything is dissolved. So I'm going to go ahead, hit stop. And you see that nice curve we have there. I'll turn off this. And before we go over the graph, we're going to want to remove the conductivity probe from our solution and rinse it off for our next activity so it's clean. We'll set that aside for now. And then we'll get a tweezers to remove the stir bar. Rinse that off. Put that aside. So once we've cleaned off our conductivity probe and our stir bar, we're going to look at the graph quick. And then we'll move on to the next part of part B. So you're going to want to sketch a copy of this graph in your notebook. It's part of your data table, or your data. It's not a table. So see that we started at 0 seconds. Since my timing was not perfect, some of the sodium chloride was already in there. So we're at 827 microseconds per centimeter to start. It looks like at around 71 seconds, that's 70 seconds, there we go. Looks like we hit plateau at around 4,040 microseconds per centimeter. So you also want to write that value down. And then I'll leave this here for a bit so you can sketch the curve and make sure to include the X and Y axis. All right, and then after we are done with that, we're going to move on to the next part. So in this part, we're going to make a diluted solution from our original solution, which is the one that we just did the curve for. And then, so how we're going to do this is we're going to take a 50 ml grad cylinder and we're going to measure out 20 to 25 milliliters of our original solution here. And then we're going to take that amount and bring it up to 40 to 45 with distilled water. And then we will take the conductivity of that solution, and you'll write that down, and then we will be finished. So once I measure this out, I'm going to have you guys look at the grad cylinder again, and I'll tell you what I think it's closest to, and then you can look at it, make your best judgment, because you also want to write that down. To me, it looks like it's actually over 25. So I'm going to put some of it in our little waste beaker here, just so we can stay within the protocol. There we go. So, it looks like it is lying right below the 25 line, the meniscus is. So I would say it's around 24.7 or 8. So I'll let you decide. It is kind of hard to see. Again, I'm going to add up between the 40 and 45 line. Pop the bubbles, and then let y'all take a look at it. Alright, so to me, it looks like we are, if I could hold it still, looks like we're right at the 43 line. So either 42.9 or 43.0. I'll let you make that judgment. We'll go back to the setup we had before. Now that we've completed making our diluted solution. So now we're back at our stir plate with our clamp holding our cleaned conductivity probe and our rinsed, clean as can be. Now we're taking a 100 ml beaker that we're going to put our solution in, and then we're going to take the conductivity of our diluted solution. You'll write that down along with each of the volumes that you decided. And then, once you're done with that, you'll be able to do your post-lab with all the math and the curves you need to draw. So, oops. The cords are screwing up our setup. There we go. Not touching the bottom, not touching the sides. So I'm going to take the grad cylinder we measured from and pour it in. We'll go back over to the LabQuest. And we can see if it focuses. There we go. That we're at about, see, these probes aren't the most accurate, so they have a hard time stabilizing. So it's going to do this for a while, and my suggestion is to just choose something that is in the middle. So it looks like I would go somewhere around 2, 3, 5, 7, 6. But you want to make sure you write down this number. It's important for the end part of your post lab. So remember, it's in microseconds per centimeter. And once you have that written down, that concludes part B of the Ionic Solutions lab. So, happy sciencing!